What's going on, everyone? Hope you guys are doing fine. So I've been catching these debates online on TikTok. First of all, I want to give all the credits to Angels of Light. He's the one who has been debating these globe believers. So shout out to you. Give him a follow if you are on TikTok. So these guys, they don't think of their own. Like they have been instructed to deny that the speed of the Earth is roughly 1,040,000 miles per hour at the equator, 1,600 kilometers per hour at the equator. So they have all been instructed to deny this, and they use numbers like rotations or degrees. So this video is going to be to address this. We're going to be listening now a couple of professors, university professors, and since I was a kid, I have learned the speed of the Earth in kilometers in Brazil, 1,600 kilometers per hour at the equator. And I can say this is the same in different countries, different languages. We all have learned that, but now they have been denying this very fact. So let's go ahead and take a listen to these guys stating that the speed of the Earth at the equator is in fact 1,040 miles per hour or 1,600 kilometers per hour.
Well, NASA doesn't have to perform an experiment to prove that it's moving at 1,000 miles per hour. You can figure out that at the equator, the Earth is moving at about 1,000 miles per hour from a reference frame that is outside of the Earth.
So the equator is about 25,000 miles around, and it takes 24 hours for one full rotation.
Okay.
So if you divide those two numbers, you get approximately 1,000 miles an hour.
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
Or 465 meters per second.
As we know that it's turning 24 hours, the circumference around the equator is about 24,900 miles. And we know it rotates once every 24 hours. So you just divide 24 into 24,900. It comes out to 1,037 miles an hour.
Distance is equal to circumference of the Earth, and time taken is equal to 24 hours. So when we calculate, it becomes 1670 kilometer per hour.
Since the circumference of the Earth is roughly 25,000 miles, and it takes 24 hours for one day to happen, 25,000 divided by 24 is roughly 1,000.
1,041 miles per hour.
As the Earth rotates, the equator is going the fastest. You're going about 1,000 miles an hour.
So there you have it. So let's go ahead and start listening to these debates, and I will be commenting on as we go along.
Chuck, how fast does the Earth rotate the equator in your model? How fast in miles per hour?
In miles per hour? Well, here's the thing. We don't measure rotation in miles per hour.
At the equator, the Earth is moving at about 1,000 miles per hour.
So here's the thing you want me to say, so I'll go ahead and say it.
What is the speed?
We'll go ahead and say it. I'll just go ahead and say the thing you want me to say.
Yeah, what
it's
is it?
1,000 miles an hour.
Okay.
How about that?
And how much is that
Is that
in
what you want me to say?
second?
1,000 miles an hour?
Yep. How much in 1 second, Jardok?
Well, I don't know. I'm not going to calculate that off the top of my head.
1,500.
You calculate it off the top of your head.
1,500 feet.
All right, cool. Who cares?
The whole scientific community?
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
So if I throw a ball up for 1 second, does it deviate?
Does the ball go up?
1,500 miles per hour?
Conservation of momentum.
Oh, so now there's no Coriolis right now. Thank you. You just debunked Coriolis. Thank you. So the ball does not deviate. There's no Coriolis effect to prove that then. Thank you, Shadow. Thank you,
You literally said the ball deviates.
Coriolis effect, an effect whereby a mass moving in a rotating system experiences a force, the Coriolis force, acting perpendicular to the direction of motion and to the axis of rotation. On the Earth, the effect tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern.
Coriolis. You don't know what Coriolis is, you
said conservation of momentum.
Yeah, conservation of momentum. So I'm standing at the equator, I throw a ball up and it doesn't fucking move anywhere, right? But if I...
Let's look at the planetary rotation. Does that
does
that not engage with a field kick?
So if you have a north-south stadium, and many are, if it's oriented that way, and the kicker kicks the ball, depending on how high and how long it's in the air, the rotation of the Earth can have a significant effect on its trajectory towards the goalpost. If you're trying to make a 50-yard field goal, that's far away enough, and the ball is airborne long enough for the rotation of the Earth to deflect it to the right by 1/3 of an inch.
I throw a ball up, straight up in the air at the equator, it lands back in my hand.
Have some more fluoride water. You're just yelling at me.
No.
Okay, check this out right now. If I throw the ball north at the equator, does it deviate 1,500 feet sideways?
The further away it travels from the equator, the further towards the right.
Okay, so Ranhan, now that I've thrown the ball forward, right, it doesn't deviate 1,500 feet. Right, Ranhan? It doesn't deviate 1,500 feet sideways? How come, Ranhan? Go on, say conservation of momentum again. Disprove Coriolis again.
So, you don't wonder why people get triggered, dude. You're a
because you've got no argument to actually beat me, so that's what happens. You have to insult me because you don't know anything about what you're talking about. So triggered. Look how mad he is, dude. Look how mad he is. He's like 60 years old, still doesn't know what Coriolis is. You said conservation of momentum, so you're denying Coriolis. Please elaborate how you destroyed me on Coriolis. Please elaborate.
Yeah, by you saying that if I throw a ball up and it lands back in my hand, that defeats Coriolis. That means Coriolis doesn't exist.
Yeah, and it drifts
sideways. He's not being like that towards you, so just chill so I don't have to mute.
So, conservation of momentum.
Oh, so you deny Coriolis.
And now you're gonna go, oh, so Coriolis doesn't exist.
Oh, so hang on. We didn't observe Coriolis because of conservation of momentum. How does that prove Coriolis?
Throwing a ball up, right, and it drifting sideways, it doesn't happen, and that's not what Coriolis is.
Coriolis doesn't exist. I throw a ball north at the equator right now. Does it deviate 1,500 feet sideways because of Coriolis, and that's how fast the Earth? I throw the ball a meter in front of me and it's in the air for 1 second. Does it deviate sideways 1,500 feet?
No.
Oh, why not? The Earth just spun
because it was coupled to the Earth at the time you released it.
Right, so then no Coriolis. No Coriolis then. Thank you guys for denying Coriolis.
If a soccer match is taking place right at the equator where Earth spins 460 meters per second or 1,500 feet per second from west to east, would the player be able to score, or would Earth under the ball spins from west to east? If the ball is moving with the Earth, then Coriolis effect does not exist. If the ball travels 3,000 feet in 2 seconds and Earth under the ball is moving from west to east at 1,500 feet per second, that means the ball would land 3,000 feet to the side of the goalpost.
And I tweeted, the winning field goal in that game was aided by a 1/3 of an inch deflection to the right from Earth's rotation.
Documents say non-rotating and the pilot does not have to adjust for Coriolis. Were you wrong by saying that that's just for simplification?
False premise. I said the pilot does have to adjust. He just doesn't notice because it's a tiny hair's breadth.
Was it a tiny bit when the Earth rotates at the equator 1,500 feet per second?
Because it's relative to the ground. It's not. You can't take an absolute linear movement and equate that.
Number 5. You just denied Coriolis 5 times. Okay, check this out. If I hover a drone above a spinning merry-go-round, does the merry-go-round spin underneath the drone?
Okay. Have you ever worked a blender, Angel?
How about if you answer my question,
No, it doesn't, because the merry-go-round is not moving the air around it.
Okay,
that drone
so now,
is coupled to the air, which is coupled to the Earth rotation, not the rotation of the merry-go-round. This is
correct. So
right?
now
Is that true?
Yes. So now,
right, when you spin a merry-go-round, does the air around the merry-go-round swirl around and everybody starts to fly towards it?
Hang on 1 second.
No,
so
I did not.
Okay.
The merry-go-round's actually a good example of Coriolis. Try to throw a ball somebody
because it's
in the merry-go-round across the way.
Yeah, so why does it work? Why does it work with a ball but with not a drone?
What do you mean?
Well, 1 second. So if I do the drone now on the equator, does it deviate sideways 1,500 feet every second?
It is going at the same rotation rate as the Earth. It is coupled to the atmosphere, and the atmosphere is rotating with...
How come Coriolis works on a rotating system but not the Earth?
It works on the Earth. It's just omega
just
small.
denied it 6 times. You said conservation of momentum. So you're saying the atmosphere moves with the Earth? Is that what you're saying?
Yes, the atmosphere is coupled to the Earth. Just like when you turn a blender on, eventually all of that stuff starts spinning.
We have learned that air particles are independent from each other. What's inside a blender is normally liquid or solid like ice cubes. This professor cannot compare a gas to solid or liquids. See as this girl jumps into a pool full of independent plastic ball. Her jump does not affect the other side of the pool.
And the stuff near the blades is spinning at the rate of the blades, but it doesn't start that way. It takes a little bit of time.
Because he just said that the Earth, the atmosphere is velcroed to the Earth. How come clouds move in all directions? And they're part of the atmosphere.
So relative to the ground, they're not moving that fast, but there are local disturbances in the atmosphere, man. We're not saying that the atmosphere is a rigid body. It is a gas. Right? This is a gas.
So again, does the helicopter velcro itself to the atmosphere?
The helicopter, when it is on the surface of the Earth, it is moving with the Earth. So it has that velocity, that inertia. So when you lift it up, it still has that velocity and it has inertia. It's going to stay there. And since the wind is moving with the Earth, there's nothing to deviate it.
So, it's just like saying Earth is stationary and only things that are on Earth are possible to measure speeds, but not Earth itself.
And so
why the bullet then? Why does it change with a bullet? When that bullet leaves the ground, it's going the same inertia as the ground, right?
It is, yes.
So then why would someone have to account for Coriolis if it's leaving the same the same spin rate?
That's a good question. So when we do this long-range artillery, the only control you have on that projectile is the initial condition you give it. You have to give it initial velocity and some direction. That's all you have. You can no longer make adjustments. But with the air
But what do you account for when you fire that trajectory off?
So you have to account for every possible deflection it's going to suffer, and the Coriolis is
what
going
is
to be
every
even if it's
possible
small.
deflection?
How much?
Okay, here's what I need.
Gravity,
in order for me to get behind Coriolis at all, there would have to be a sliding scale that would have to account for the cardinal direction and the cardinal direction that you're at and the longitude that you're at on the Earth, right? So depending where you are away from the equator, north or south, and depending on what direction you're facing, there would be a different value for what you would account for. Do you have that table?
So mega cross feeds. So the spin rate of the Earth cross, which is basically a fancy multiplication into the velocity. So this is just directions. The Earth spin axis, we typically say, is in the Z direction, and your velocity is going to have some direction relative to x.
1 second.
Oh, and we have Blitz here, so he can help along with the math of this.
Blitz.
Howdy. Hey, Blitz.
Hey, Blitz. How are you?
Hey, what's up, Blitz?
Just wondering, Blitz, the helicopter is in the atmosphere. Is it velcroed with the atmosphere? Is that what you're saying? That's
Obviously not. It's a straw man of the position to say so.
Okay, can you explain to me? Can you explain to me why there's no deviation of the helicopter that's hovering on the equator?
In particular, the helicopter is in air that is so close to the ground on the scale of the Earth that it's effectively on the boundary. The ground is effectively, or the air is effectively not moving with respect to the ground for this reason.
What about if it's a kilometer up?
That is very, very small on the scale of the atmosphere.
So the Coriolis effect does not affect a helicopter 1,000 feet up in the air, but affects a ball 20 feet up in the air.
The rotation of the Earth can have a significant effect on its trajectory towards the goalpost.
Why is it very small?
Because the atmosphere extends up 100 kilometers and the Earth is 4,000 miles in radius. It's 1 kilometer is very, very small.
Let me simplify this. If we hover a drone on a spinning merry-go-round, right? The merry-go-round spins underneath the drone, right?
Yeah, so the merry-go-round is not in equilibrium with the gas around it.
So if I hover
the Earth is in equilibrium with the atmosphere.
How fast does the Earth rotate in 1 second in your model at the equator?
It rotates once per day.
How much is that in miles per hour?
I don't measure rotations in miles per hour.
At the equator, the Earth is moving at about 1,000 miles per hour.
Yeah, that's a tangential.
Not a useful notion.
So hang on. The Earth, when I Google it, right, is Google lying about the Earth model when it says it's 1,037 miles per hour?
That's not a rotation rate. That's a tangential velocity.
That's a literal rotation rate.
Well, if some website on Google says that that's the rotation rate, then they're using the language incorrectly.
Because right now, here in New York, you can calculate at our latitude, we are all moving with the Earth at 800 miles an hour.
Okay, so does the Earth move 1,000 miles per hour at the equator sideways?
You know, if I can just quickly add, in my kid's school book, it actually talks about the lineal velocity speed of the Earth's spin. It doesn't talk about the RPM. It doesn't talk about one.
I'm sorry that
rotation
your
a
kid's
day.
school book is
increasing
flat earthers by using language poorly, increasing the number of flat earthers.
No, Blitz. I'm saying that this is how it's always been.
It's I've taught physics at a university level for years. That's not how we teach it.
Okay, can you answer this question?
My 8-year-old's not in university, Blitz.
Okay, so why not we pay attention to what's taught at university rather than to 8-year-olds?
No, the indoctrination starts early.
Education. That's called education, man. Not
that's indoctrination, George.
It's
when you deny that that water sits flat at rest.
Oh my gosh!
And nobody has denied that. Here we go.
Okay, what's flat? Can you tell me what level is?
Wait, let's not switch subjects. They haven't even answered the Coriolis.
Perpendicular to down.
They're literally
it's perpendicular to the relative force of.
Yeah, it's just perpendicular to down.
One second. Blitz. Does the Earth move on your model at the equator 1,037 miles?
Relative to what?
Relative to the rotation? How much degrees?
The rotation isn't a place or a reference frame.
Yeah, I'm pretty sure Angels of Light does not know what the phrase
motion relative to
Does the Earth
reference frame.
rotate 15 degrees per hour?
Sorry?
Does the Earth rotate 15 degrees per hour?
Sure.
How much is that in miles per hour at the equator?
That is relative to what?
The Earth rotating. How much is that?
You're asking how quickly does the Earth rotate relative to the Earth's rotation?
How much does it move?
It's a nonsense question.
How much does it move in an hour? East.
Relative to what?
Are you this thick, dude?
Angels,
Wait, do you know what the answer? Do you know what that question is that I'm asking you?
Are you seriously? Hang on. Are you seriously?
You guys can't even miss the speed.
Already, we're trying to get.
I use language in a very precise way.
Okay,
I don't know if you guys do. I use language in a very particular way, in a way that has strict definitions.
Per hour.
This guy, Dr. Blitz, uses language to deceive his viewers.
Relative to what?
Relative to the Earth's rotation.
That's not a place or a reference frame. It doesn't make sense to talk
relative
about motion
to your
relative to
space.
motion.
How much does it move at the equator in miles per hour, please?
Relative to what?
Relative to not being on the Earth.
Relative. Okay, so what? How quickly is that reference frame moving?
Dr. Blitz,
when you're not on the Earth?
If I'm on the equator, standing on the equator.
No, Blitz is being disingenuous. That's the problem.
Being disingenuous.
He knows the fucking question and he's dancing around it.
He's not.
How much does the Earth rotate at the equator relative to you standing on it? If I'm standing on the Earth at the equator, do I rotate?
So surely you rotate, yes. You rotate about a particular axis.
How much distance have I covered at the equator in an hour?
Distance measured relative to what?
Dude, you can't be this. Dude.
We measure distances relative to. Look, when you measure distance, you're measuring from A to B.
Okay, when your model claims that we're traveling such and such light years through space in a year, where's your reference point?
There is no model that's claiming we're traveling such and such light years in a year.
So when you ask
there's not a single model that makes that claim.
How can you get angry?
What distance do we travel in a year, Blitz?
Relative to what?
You can't be this.
Oh my. This is ridiculous.
It's actually a good question. He's just
relative
trying to get to the
relative to the beginning
here.
place of your space. You know exactly what I'm asking.
Place? There is
you know
no
exactly what
place.
Angel of Light is asking.
If he's asking how quickly does someone on the equator move relative to somebody on the North Pole, that's about 1,000 miles per hour. If you're asking
your
how
model
quickly they
claims
move
that we're
relative to the
orbiting.
sun,
According
what
to
you're measuring relative to.
According to NASA, nspace.com, they give us speed. So you're denying NASA, you're denying space.com because you don't even want to admit to a speed.
Yeah, he's just being ridiculous.
Around
Complexity is precise. If you don't like precision, get out of science.
Why does space.com give us speed? Why does NASA give us speed? Why can't you give us speed? Okay,
Because if you want to talk about velocity,
NASA gives a speed.
Defined?
Google gives a speed.
Do you know what velocity
Wikipedia gives a speed, but you can't give a speed.
Do you know what velocity is?
Say 1,037
Every
miles
source
per
you
hour.
go to gives a speed. But
I don't care what sources say. I use language in a precise way. If you don't like that, then
Okay,
don't ask
can you
questions. I
please-
guess.
Can you please use language and just say this number, please?
Who the f made you the authority on how you communicate like that? The question is very
This is
clear.
how I communicate. If you don't like that, then
It
ask
is
a different question.
ridiculous. It is
You know what it- hey,
ridiculous.
guys,
You're living in your own world there, Blitz.
Hey, guys,
No, Jorge, hold on. You fucking defending this is bullshit too. You know exactly what we're fucking asking. Both of you being disingenuous right now, and you know exactly what the question is being asked.
When y'all
there's
talk to me-
fucking literature. Hold on. There's literature and books all over the place about how fast we're going through the universe, how fast we're spinning, how fast the universe is going. It's ever expanding. All this bullshit. No, hold on, Jorge. Let me finish. If we're asking how fast we're traveling, how fast are we spinning, you know exactly what we're asking, Blitz. It's what the fucking knowledge is that you learned. Answer the question and stop being disingenuous, man.
I'm sorry that you're reading from like pop sci news articles and Wikipedia and Google.
No, now you're straw manning. Now you're straw manning. No.
Literally,
You do not know what books that I got my knowledge from. What, Popular Mechanics? Is that what you're going to cite? Dr. Blitz, do you teach out of Popular Mechanics?
Literally, somebody just pulled up.
I don't care if you want to claim that your university is a street corner and you're reading out of Popular Mechanics, Blitz. You want to add Dr. to the front of your name? Well, you want to straw man where I'm coming from. I'm going to do the same to you.
Hold on, Mike. Hold on.
Wait, did somebody not just cite Wikipedia, Google, and
Did you not just cite that I got my information from some fucking magazine?
Was it not you who cited?
No, you want to play that energy? I'll give it back to you, pal.
Maybe it was somebody.
You ready to let your long hair down?
Mike, who cited space.com? Was it not you? Okay, I'm sorry. I got you confused, Mike, with Rip Globe.
It doesn't matter. It doesn't matter. When you look it up and you've got all these sources that are saying the same number and you can't spit out a number, everyone here is watching this, Blitz, and you're being disingenuous, man.
All I'm asking for
You're supposed to be an authority on the topic. This should be an easy question for you to answer.
You're in denial, Mark. You're not accepting what they're saying.
Guys, stop.
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
When they can indoctrinate the masses of children with this knowledge and give them a number, but you can't, that's where I'm going to call you disingenuous.
You can call me disingenuous if you want. I just use language in a precise way, and if you don't like that, tough shit. That's how we do science.
I literally just told you in a precise way.
You told me in a precise way what you're measuring relative to. Well, then where do you want?
No. I told you in a precise way that you're being disingenuous. They want to teach the masses these figures, and you can't string out a number that they teach in grade 4 science.
There's multiple.
I'm sorry that you feel that way.
Blitz, how much do you get paid?
It's not that I feel that way. It's crystal clear. I'm stating an observation. It has nothing to do with feelings. It's facts, pal.
Okay, well, peer review seems to disagree because I don't think Jorge, who is your peer, disagrees. Actually, Jorge is not your peer, so...
Jorge is not my peer.
I know. That was my mistake. He's not.
Dr. Blitz, how much does the peer review say? How fast do they say the Earth spins?
I've never seen a peer-reviewed article that actually uses that kind of language. So
why not? Why not? You reckon? Why?
Well, just because I don't go back and look at peer-reviewed articles from the early 1900s, because it's just not particularly interesting. I mean, I have on occasion.
So wait, did the Earth stop rotating since then?
No, it's just people aren't investigating this because we've known the Earth is round and spinning for 2,000 plus years.
Oh, so
it's foundational. It's not
spinning, right?
Of course, it's spinning. Yeah.
Oh, how fast is the equator again in miles per hour?
It's spinning 1 rotation per day.
And how much is that in miles per hour?
At the equator, the Earth is moving at about 1,000 miles per hour.
There's no direct conversion rate between.
As the Earth rotates, the equator is going the fastest. You're going about 1,000 miles an hour.
What's the circumference of the Earth?
The circumference of the Earth?
But no, Blitz, you can give it miles.
Is it 24,901 miles?
About 25,000 miles, yeah.
Okay, so if you do the math on that, and 15 degrees per hour, right, around the ball at the equator, how fast has it moved in miles per hour? Is it 1,000?
So I mean, look, we can go over the math if you want.
Hang on, yeah, let's go with the math. If I throw the ball, does it deviate 1,500 feet in 1 second? at the equator.
Why would you expect it to?
Because according to your globe cartoon religion, the Earth rotates 1,500 feet in 1 second. If you do the math, like you love math. So the Earth is on a rotating axis, right? And it spins 1,040 miles per hour as measured at the equator, which you keep denying, right? This is 460 meters or per second, or 1,500 feet. One complete rotation is called a day. Now, can you please, seeing as you love math so much, how would you do the math on that? If the Earth is 24,901 miles in circumference, and it moves 15 degrees per hour, which is 1,037 miles per hour, is that 1,500 feet approximately in 1 second? Blitz, can you do the math, please?
That's not how motion works. You have to account for all of the possible effects on the motion, which you're not doing.
We know the circumference of the Earth is 40,075 kilometers. Divide 23.93 hours into the circumference, and you get 1,675 kilometers per hour, or 465 meters per second.
So if I throw a ball north, right, and it's in the air for 1 second, how much will the ball deviate?
So how fast are you throwing it?
I throw it 50 miles, and it's in the air for 1 second.
If it's in the air for 1 second, it probably won't deviate much because the Coriolis effect over small scales is not very much.
Hang on, the Earth just moved 1,500 feet though.
It is moving moving north in the rotating reference frame relative to its initial position, which was stationary.
Why does it start off stationary, dude?
With respect to the Earth.
So the Earth has no Coriolis then?
Look, when a ball is sitting on the ground, it's stationary with respect to the Earth.
You mean with respect?
You understand that, yeah?
No Coriolis. How many reference frames for Coriolis splits?
With respect to the Earth,
you just need one reference frame.
What?
As long as Coriolis occurs in a rotating reference frame. You just need the one reference frame. In this case, it's a rotating reference frame of the Earth. That's where you work because we live on the Earth.
But you just said it's stationary.
With respect to the Earth. Meaning that in the reference frame of the Earth, it is stationary. In the reference frame of the Earth, it's stationary. You're still working in the Earth's reference frame.
How the fuck are you the science communicator, dude? You just denied Coriolis again.
Engels,
I didn't, but it might sound that way if you don't know what I'm saying.
You like 20 times in your life, dude.
Smart. If I'm on a merry-go-round and I throw a ball, does it deviate? If it's spinning, the merry-go-round spinning.
It depends on what direction you throw it.
If I throw it just in front of me,
which direction are you facing?
Let's say you're facing the center and you throw it towards the center. Yes, it will deviate. Just to simplify for you, Angels.
Right. So how come that doesn't happen?
That does happen.
It'll deviate in every angle that you throw that in.
That doesn't happen on the
Earth. When you throw a ball from the equator, are you throwing it towards the center?
North. I'm throwing
Is that towards the center?
No, I'm throwing it in front of me. North.
Right. So why would you expect the same thing to happen on a merry-go-round when you're throwing it towards the center compared with when you're standing on a rotating Earth throwing it north? It's different initial conditions.
And also, Blitz, the omega, the spin rate of that merry-go-round. Imagine the merry-go-round
much higher.
Imagine the merry-go-round turned once in a day. Just imagine the merry-go-round turned once in a day.
The Earth is really big. Remember, I thought you guys knew scale, guys.
Yeah, the Earth is really big. That's why the Earth's rotation rate, even though you keep citing this mystical number of 1,000 whatever.
Hey, Blitz, if I face north, right, am I rotating with the Earth that I'm standing on?
Yeah.
Does the Earth rotate 1,500 feet in 1 second?
Relative to the center? Sure.
Okay. So how come the ball doesn't deviate like the merry-go-round? That's not that
You can calculate the deviation force that you would have, and when it's on the equator, the force will be the force will be 0 if you're throwing. No, actually, the force won't be 0, but it'll be pointing downward. Let me just do a quick cross product. So you have the omega. You have omega cross. Oh no.
How come
I'm sorry. If you're throwing it north while you're at the equator, that's not the case. If you're throwing it east or west, then there would be one. Yeah.
Do you believe in Coriolis? Does the Earth have Coriolis?
Absolutely.
Oh, where?
What do you mean where? It happens everywhere on the Earth. It just depends on the direction that you throw things in.
Where's everywhere?
Whole globe.
Wait, hang on. Dr. Blitz just said the ball doesn't deviate at the equator. Now he's saying everywhere.
If you throw it north, it doesn't. If you throw it north or south, it doesn't. If you throw it east or west, it would.
All right, guys, this is all for today. It was extremely painful to hear these professors. No wonder, the Rockefellers, all their plans to make people workers and not thinkers. just slaves, and another quote that says, teach them everything about nothing. So you have all these professors teaching all this nonsense. You know, I'm glad I was able to talk my daughters into not going to college. They're working, they're making just as much money without having to put up with all this nonsense. Take care, guys. See you the next time. Bye-bye.
Don't waste any more time. Visit the links above now and order my book 16 Emergency Landings Proving Flat Earth. Visit my online store now and order the new enhanced Gleason's Flat Earth map. This map used to be in every school and library in the nation before NASA was created in 1958, when the maps were ordered removed. Have your Gleason's map hanging on the wall in your house where no government can take it down. Here you see it hanging on a wall in the house of the late Charles K. Johnson. Here is a quote from the book 1984 by George Orwell. Every record has been destroyed or falsified, every book rewritten, every picture has been repainted, every statue and street building has been renamed, every date has been altered, and the process is continuing day by day and minute by minute. History has stopped. Order your map now.